again, this is the problem in series of the latest sample paper class 12 set 2. So here, as you can see, inverse of the matrix is given to us. So whenever inverse is given, what does it mean? It means that definitely I'll get identity matrix once they are multiplied, right? Like if I say in multiplicative inverse of 5 is 1 by 5. So when I do so, I get 1, isn't it? Now what is 1? It is the identity, multiplicative identity. So similarly, in matrices also, if it is given inverse of this matrix is this, their multiplication will give us an identity matrix. So we have to use that concept only, like A inverse is identity. Directly they are solved in the fashion of using some condition, some property. So here that will be used. So it is a 3 by 3 matrix, so I'll get identity matrix of order 3. So let's multiply them first and check what the result is. So I'm writing it again, and we have to multiply it, and then we have to compare both sides of the equation, and we must get an identity matrix, as this is the inverse of this matrix we are already given. So using the definition of multiplicative inverse, we are solving. So here let's solve row with column. This is 7 and minus 3 is 4 minus 3 is 1. Again 7th is a 21 minus 3 lambda, so 21 minus 3 lambda, and this is minus 9. 21 minus 9 is how much? 12. So let's write 12 only here, because the like terms gets added, right? 7th is 21 and minus 9 is 12, and 12 minus 12 is 0. Now let's go to the next row. Minus 1 plus 1 is 0. Minus 1 plus 1 is 0, and again this is 1. Now next is minus 3, and this is plus 3 0, and we are left with only lambda. Next is minus 3 plus 3, and we are left with this 4, and this is minus 1, and this is 0, and this is plus 1. I get 0 again, and here I get minus 3, and this plus 3 gives us 0, and 0 into lambda is again 0. This is minus 3 0, and here I get 4. Okay, this is this is minus 3, this is 0, and this is 4, so here I get 1. Now let's recheck some more values, like what I'll get here. This is minus 1 plus 1 is 0. Oh, see, I was assuming that some error is there, so this is 0. So I'll get 0 here, because minus 1 plus 1 is 0, and this is again 0. And let's recheck this entry also. Minus 3 plus 3 is 0, and 4 into 0 is 0. So because both the side have to be equal, right? So I was wondering how I'll get different thing. And let's check this value also. So 21, and 21 minus 9 is 12, and this is minus 11. So obviously let's check. 7 3 is 21, and this is minus 3 lambda, and this is minus 1 3 4, and this is how much? This is minus 9, and okay, so I am getting 12 minus 3 lambda here, and 1 0 0 0 1 0, and here I get 0 0 1. So, and here if I check this value, I get minus 3 plus lambda, so this is minus 3 plus lambda, and this is 0. So minus 3 plus lambda and 0. Okay, so now when I see that these two matrices are equal to one another, so I have rewritten for better quality. After multiplication of the two matrix, I get this matrix on the left hand side, which is to be equated with the identity matrix, because the matrix given were inverse of each other. And now as the two matrices are equal, their corresponding elements are equal, right? So if I compare 12 minus 3 lambda with the same position element, it is 0. Or if I compare this with the corresponding element, like minus 3 plus lambda is equal to 1. So what do I get? I get 12 is equal to 3 lambda, or lambda is 4, right? 3 minus 3 4 is 12. So lambda value is 4, and from here also I see 1 plus 3, it is 4. And obviously I must get the same value for any of the corresponding elements once they are equated, right? So the answer for the given question is lambda is 4. So this is the solution for the given problem when one matrix is the inverse of the other matrix. Thank you.